Good morning and a warm welcome to you all on this fourth session of two-day workshop on geometrical interpretation of mathematical concepts organized by GTU. We have our expert Mr. Chanchal Das. Now before handing over to him this session, I would like some of our participants to give us the feedback of yesterday. So yes, Mr. Adarsh.
It was very interesting when yesterday Mr. Das started talking about mathematics. It started from a dot and how a dot kind of goes on a walk and then it becomes a wall, and then how the surfaces extend themselves to become into more dimensions and how shapes are happening. So I also teach at design institutes. So I was teaching form communication, which is basically understanding how things are made and formed in the physical domain of things. Even with that course, it starts similar, that a dot is looked at as the minimum possible representation that man can do, and how it extends itself into becoming different shapes. And from there the interpretation kind of is, after learning the basics, we start using the pencil and clay to really understand how formation happens. But here it's numbers. So I see a very interesting parallel that could be, for either ways, for learning mathematics and to learn design. It's about perspective. The more perspective you have about understanding a certain concept, the better application is possible, according to me. So it was really interesting. I hope I'm able to kind of use it to bridge and make understanding and application of courses more interesting.
Thank you, Mr. Adarsh. Anybody else would like to suggest something? Any feedback? Hand over the session to Mr. Chanchal Das. He would take us further.
Okay, thank you and good morning to all of you, and I welcome you all in the fourth session of this mathematics workshop. And yesterday I have covered many of the items, and I have covered that through a line you can do any sort of things, that is starting from your solving the mathematical problems like solving the functions or any other things, geometric construction, and making any object in the world. So if you have control in line, you have control in everything in this world. So continuing with that pace, and today I will be covering more about dynamic world, how we can handle our dynamic world. So today's topic will cover this exploring dynamic world. I will go with this dynamic world, and I first try to explore what is dynamic world means, when it will be dynamic, when I will say an object is dynamic.
It has some speed.
It's moving. Very good, yes. So first requirement is moving. So what type of movements we have?
Linear and curved.
Linear is not a movement. This is something.
Movement where the shape of the object
rotational.
remains same or the shape of the object changes.
That is also a movement, no?
Yeah.
Deformation.
Yeah.
So you can say that, yes.
two kinds
Any
of
other?
movement.
Translation and rotation.
Yes, yes. That is the most fundamental thing. Translation. Translation. What else? Rotation. You told rotation. Very good. Rotation. What else? And you told shape. Shape means it is, to some extent we can tell as shear, gets deformed or something. Any other things?
Shearing.
Shearing.
Skewing.
Skewing we
shearing.
can cover with shearing.
And then scaling up, magnifying.
Scaling. Very good. We can scaling. And any other thing?
Projection.
Projection. Very good. Projection, why we should say is that moving in that sense,
The camera is probably moving.
No,
or
no, not like that.
The
This
perspective is
object,
changing.
this is a 3D object, but when I see it, I don't see it as a 3D, I see it in a plane.
2D projection.
So, 2D projection. So, in one sense it is projecting, we are projecting a 3D object to a screen sort of thing, a plane, and it is we are seeing. So, we can tell that it is also moving something. So, this is projection. And any other things?
Reflection.
Very good. Reflection. When we stand before this mirror, we see our reflection. So, in nutshell, all the dynamism in this world, involve these 6 type of movements, and if you can handle these 6 type of movements, you can handle any type of movement in this world, very simple. And the beauty is that for moving this 6 type of movement, you require only one matrix, and if you learn that matrix, you can transform any object. So, this subject is actually transformation. And what we call linear transformation. What is linear transformation and non-linear transformation? That is again different subject, but this is a transformation, all these 6 things. So, today we are going to do that. So, main topic will start, if we start from transformation, then we will not knowing what for we are learning this transformation. But the way you think in this, we are handling a dynamic world movements are constituted this type of movements, these 6 types, and we can handle this with a matrix which is called 4 into 4 matrix. We will reach that in later, and entire subject is called linear transformation. So, this is the requirement for learning linear transformation. We will do that. Okay. Before moving, again few things actually we should get cleared about reflection. Yesterday we told reflection. For a reflection, it is not a 2D phenomena, it is a 3D phenomena. What does that mean? 3D phenomena. Suppose I stand here and there is a mirror. So, my mirror will be there, that side, image will be that side. So, that image is forms not in this same plane, it moves like that 180 degree, but in z axis, means other axis, not in same plane. But for the rotation, if I rotate like that, I will move like that, my head will go down, and 180 degree I will move in the same plane. This is the rotation. So, there is subtle difference between rotation and this reflection. And similarly, when we will move from 2D to 3D objects, then there will come again another parameter z axis. So, that will again create some problem, but complexity we will solve that also one by one. So, first thing we require a matrix. So, we will start with that matrix, and first we will try to move one point 5, 3 and 5. Just in your Excel sheet we will start practicing from this. You start your 3 and 5, and this is your x and y. You can term it as x and y, and you have a transformation matrix first. Transformation matrix. So, it is like that. This is a requirement for a matrix multiplication, that if I have 1 row and 2 column matrix, I require a first thing I require a 2 row matrix, because this column and this row should match. So, we will get a 1 into this will be our output. So, what we will get this x y, when it will be multiplied by a matrix, we will get another point or vector. Yesterday I clarified why I should not call it as a point, it is a vector. So, it will transform like that and term this A, B, C and D, that is all. Now, you have liberty to take A, B, C, D any values. So, depending on this A, B, C, D, these values will go on changing. This equation will be 3A, 5C and this is 3B plus 5D. These values will come depending on what A, B, C, D you have put, you will get this. Very easy. And yesterday I told how to do matrix multiplication. What you have to do? First you have to select both the cell, output cell, it is 1 into 2 and there you have to write like that. This is the command matrix multiplication. So, I encourage you to use this command, not manually calculate as I have shown there. You should get this one. Up to this, okay? Everybody raise your hand, completed? Very good, you are done. So this is a simple thing, and you see that how these things will be extended as you like. First we will extend, I had a point, now we will go towards a line. What is required? Line is a joining of 2 points, it will have 2 vertex and one this edge, you can say this is we term in mathematical language edge. So, 2 point, 1 edge. So, 2 point you draw, computer will automatically connect it. So, we will get a line. So, here you take another point 5 and 7 and same multiplication you have to do, and you will get another here, as this is 2 by 2 matrix, you will get 2 by 2. So, here it will be this will be 5A plus 7C and this will be 5B plus 7D. You will get these values. You can remain this constant, that is all. So, every time you need not learn new things. Matrix multiplication is same thing. It will be it can be applied in point, it can be applied in line, it can be applied in any shape. Okay, raise hand, completed, very good. So, now I will move towards a line, then we will move towards 2 lines. Yesterday we have practiced that we will not follow now. What I have done, if these 2 lines we draw and we multiply, if these lines are parallel, it will always remain parallel, it will not distort any time. But these lines, if it is a intersecting lines, but we cannot ensure that this angle between these 2 lines will remain same. So, this is this knowledge you should have, first thing, that knowledge you should have, because what will be why you should know that, because suppose it is a cube and you are transforming this cube. So, you will ensure that all the parallel lines will remain parallel, whatever may be, it can squeeze, it can enlarge, everything can happen, but it will remain parallel. And another thing is that this is intersecting line, no, this edge and this edge, length and breadth intersecting. So, you cannot ensure that this angle will be 90 degree always. So, this knowledge you should know, because it can get distorted in angle, but parallel lines will be parallel. This information again will help in constructing any building, anything, and you are trying to do something want to show that different angle, how it will look like that. So, you can ensure that when you apply this matrix multiplication, parallel lines will be parallel and angle may get changed. So, if you can ensure that angle will not change, do something for that, then the whole body will be same. So, now we will extend this to a triangle. Make this triangle and apply same matrix, over. So, this size has increased or decreased, replaced or displaced, or it is in same place, displaced, and size is increased. Very good.
Stop ऐसे हो गया.
Now we have seen that this number of points can go on increasing infinitely. You can add any number of points, okay, but your transformation matrix is 2 by 2. It will not go on changing depending on your shape, whatever shape you are putting, this number of points will go on increasing, but this transformation